a product manager in cloud networking. I work on a bunch of different technologies, including related to cloud load balancing, CDN, and more recently on service mesh and some of the newer paradigms. And one of the reasons we put this panel together is there are several talks where we talk about products. So we talk about solutions. And everywhere the theme is open and it's hybrid and it's enabling new businesses, nowhere have we really paused to really say, okay, what does open mean? And especially, it might mean different things to different set of people. And then what are the commonalities amongst all of those people? What are they trying to achieve? And so I thought I'd get 4 very unique perspectives. I'll let these folks introduce themselves. But let's see what open means to them. And then we will also have a Q&A for 15 minutes in the middle where you get a chance to ask them questions. So I'll call that out once we get to that section. But with that, I'd like to start with our first panelist, Anna, and introduce yourself.
Hi, I'm Anna Bierenberg, and I'm a tech lead for load balancing, and one of the product today was announced traffic director. I've been at Google 13 years, and Prajakta is my partner in crime. We work together on a lot of products.
Hi, I'm Kelsey Hightower. I'm kind of a generalist these days at Google, focused mainly on containers and now serverless stuff, and have to deal with these folks to get the networking the way I want it. And they're great too.
Hey everyone, my name is Matt Klein. I'm a software engineer at Lyft, where I work mostly on infrastructure and networking. I spend a lot of time these days working on a network proxy called Envoy.
Bikash, I'm the CTO of Juniper Networks. Before that, I spent almost 10 years at Google building the production network that a lot of the Google services run on.
I'll probably just add some more because they've been extremely modest. So Anna drives a lot of cloud networking from the end side. She's one of the 7 distinguished engineer females at Google. Kelsey is the face of Kubernetes and Cloud Run, and now Istio, Envoy, and a whole bunch of things. Matt is the one who developed Envoy at Lyft. And Bikash is the one who developed all of Google's infrastructure and now is doing the same at Juniper. So I'm really excited to have them here. I wanted to start the question, and we can keep it free-flowing, but I wanted to start off this panel with a question, which is, we talk so often about open, and we talk about open systems, and does it really mean systems? Does it mean APIs? Does it mean something else? I wanted to get your perspective on what open means for you. And maybe we start from that end this time. So maybe, Bikash, we can start with you.
Okay, thank you. So open, from my perspective, I see 3 layers of openness. It starts with open standards, goes to open API, then it goes to open source. And from our perspective, it's ultimately something that the customers increasingly want or need or demand from the perspective of how do I get innovation velocity? How do I have control on what I'm actually deploying on my infrastructure without having the supplier of the technology having to do that? And how do I ensure security? How do I get the maximum number of eyes on the product that we're building? So open cuts to the layer, but increasingly it's a business need. That's how I see it.
Yeah, that was a fantastic answer. Probably would have been pretty close to my own. I think the thing that I would add is open to me, it also, via open APIs, open source, all of those things, it allows us to build more powerful platforms. So, one of the things that I think we've been able to do with Envoy is, because we have so many companies and people adopting it, we're seeing a cycle of, essentially vertical applications that are starting to form around that technology. And I think whereas historically we have competing proprietary technologies, that tend to, they focus their efforts on a very singular fashion. Now, yes, we can compete on vertical axes, but it allows us, I think, to actually make more progress.
I think for me, I used to say it was kind of rooted in open source. These days, I care a little bit less about that. As long as I can solve my own problems without waiting for the vendor to do it for me. If I can get that in proprietary or open source project, I feel that gives me the power to solve my own problems. So I think that's the key tenet for me, because there's some open source projects where you can't actually extend it to solve your own problems. So that doesn't necessarily fit the bill for me.
three for me is a portability, interoperability, and open standards. All of them are because we want our customers to write code once and run it everywhere. As you heard probably yesterday and today about Anthos, it's the same thing, right? You can, basically what we want to build systems that hold underneath horizontals where you can, on which you can build your business logic, one workload, and because of portability on underlying systems, you can run it on-prem and on multiple clouds. Also about interoperability, that means that control planes need to talk to each other, right? Because just running it on each cloud separately doesn't help you to make it into a single deployment, which you also want to have. So, and how you can do it all only with the open standards, because nobody wants a vendor lock-in.
Actually, that is interesting. And when I take your definitions of open, and then I think back to a lot of the open technologies each of you has been involved in, I think what would be really fascinating for the audience, because it's fascinating for me, is, so just as an example, Matt, you've been involved with Envoy. And I used to always wonder, like, why didn't you not like make a startup out of it? Or, you know, you could have like had this really fancy startup. And so in my mind, the question, and I'm sure a lot of folks in the audience as well, is these open source products that you've been involved in, what was the starting point for them? How did you think of them? How did they end up landing in open source? And like, what was your journey? And what do you think you would have done differently in retrospect for those projects? And maybe we can start with you, Matt.
Sure, yeah. So, you know, I think one of the things that has made Envoy so popular is that it wasn't started as a as a product that we were going to sell. We developed it at Lyft to solve particular customer problems. I've worked in the networking space for, you know, quite some years, and you know, I had a feeling that maybe this thing would be useful to folks outside. I did not understand what would happen once we open source. It's been a really incredible journey. But that question of starting a company and being open, it's one that's top of mind to me, and I could talk for a very long time about this, so I'll stop myself. But I think the key is a lot of people right now are trying to understand how to make money around open source. It's a very complicated topic. And I think there's two things that are often at odds, and those are about having open technologies, building a larger community. And very often when you're trying to make money on something in a singular fashion, you know, you might be looking at business models like open core, where you're blocking features, and that tends to antagonize the larger community. So when people ask me about, hey Matt, why didn't you go and start a company? We can talk after, but I don't think Envoy would be what it is today if I had left and started a company. We would not have all three major cloud providers using Envoy. We wouldn't have tens of companies building products on top of Envoy, because they would all be competing with me and my company, and that does not make a larger and vibrant community.
And I think, I mean, that's a really interesting perspective, and I wanted to add in Bikash's perspective. He comes from a vendor, and then you've had your journey with Open Contrail, and which is now Tungsten Fabric, and it's a little bit different from what Matt described. So can you take us through that? And I mean, what was Juniper, or what were you thinking as you took it through that journey?
Yeah, so Tungsten Fabric, which originated in Contrail 5+ years back, the reason that it was open sourced as Open Contrail in those days was because the customers actually asked Juniper to do it. And the reasons are what I described before, that ultimately, you know, especially in this space, companies come, companies go. When somebody's investing their core infrastructure, you know, examples would be very large carriers, all of their calls go over this infrastructure. When you're betting that mission critical application on something, you want to ultimately control your own destiny one way or the other. And having a code base that's open allows you to ultimately control your own destiny if you have to at that point. It has come a long way, and really, you know, what our vision is now with Tungsten Fabric, the reason that it changed from Open Contrail to Tungsten Fabric is I believe that the new cloud stack is built on open source. I mean, it starts from Linux to KVM to Kubernetes, even before that, OpenStack, OpenShift, or Mesos, and so on and so forth. Like it's built on open source. This stack needs a networking stack that doesn't make assumption as to where your workload is or which cloud it's running on or where it's deployed or whether it's greenfield or brownfield. I mean, as much as all of us would love all the applications to be containerized and service mesh based, a large part of the world still runs their application on bare metal. Now, how do you get that deployment on the same network stack that allows you to actually move and migrate very quickly to the modern ways of writing application, but you don't leave things behind? And I saw that stack was missing. There were a lot of networking stack that were designed for very specific things, but there isn't an open source stack that actually allows you to do all of this together. And frankly, if you are trying to go into multi-cloud, and if you're serious about it, multi-cloud are the largest public clouds, but they're also OpenStack, they're also VMware, they're also bare metal cloud that you have built, right? So we saw the need and we saw the gap, and it was sort of the obvious thing for us to sort of expand, the open source charter that OpenControl had into Tungsten Fabric, and it has been a fabulous journey.
Awesome. And then now I'm taking you back to some of the early days of Google, and I know, Kelsey, you've been heavily involved in Kubernetes for a really, really long time. Like, in my mind, you're the face of Kubernetes, and then now there's Cloud Run and a bunch of new things you're playing around with. When you think of Kubernetes, like, I hear you speak very passionately on the topic. Like, what is that journey, and then what were the tenets in mind where you said, oh, it's going to solve this set of problems really well? And I also know there are certain cases where you said, do not use Kubernetes there. So I'd actually want to hear of it from the beginning. So what got you into Kubernetes? What was the fascinating aspect of it, the community, and so on?
So I think early with Kubernetes, it's Google's entry into the container place where they have the most background and expertise at that particular checkpoint, right? So Docker is dominant. I'm at CoreOS. There's a startup trying to build Google's infrastructure for everyone else, and then Google comes along and does exactly that. So if you recognize that if that was your mission and it's now playing out, and Google's very inviting, I was able to contribute, get things merged in, and at that particular time, there's this kind of friendly war, the container wars. Lots of us have scars from the container war days. And we were all trying to capitalize on this ability to package your app and run it in a very consistent way, but that wasn't necessarily solved across multiple machines. And Kubernetes added a lot of features to make that as easy as possible, ideally competing with things like Docker Swarm, Nomad, all of these kind of easy to use distributed computing things that just try to make your environment look like something like App Engine. There was one pivotal point when we understood that the power of Kubernetes was not going to just be that. I remember we were doing some empathy session internally, and one thing that was very clear is that Kubernetes API, and when we added CRDs, custom resource definitions, to me that was the biggest game changer. Kubernetes is not just a container runtime. That is the first system that was built on top of Kubernetes. So there was a phrase that I said is Kubernetes is a platform for building platforms. The thing about having APIs and extensions, of course you can extend it, but you can only do what that interface provides. Hey, here's a network extension. You can only do what the interface provides. In the Kubernetes world we made it a very first-class thing to make custom extensions that had nothing to do with the rest of the platform. You want to build a CI/CD system, make a CRD, and we would generate all the client bindings. RBAC will be applied even to your custom extension. So we became a framework for building extensions, and that's very different than just having a plugin interface over a limited framework. And that was key to me of letting people solve their problems. So to me, it wasn't just because Kubernetes was open, it was because it was this open framework for you to solve any problem that you wanted to, regardless if you got community consensus or not. And I think that was the pivotal point when Kubernetes took a life of its own.
And coming to Anna, so the reason I saved Anna for the last is I have a lot of visibility into some of the systems she's built at Google. I do want to, oftentimes we hear that oh, but we are not Google. And I think a lot of the paradigms that were built at Google are not necessarily meant only for Google. And a lot of the systems were born where we wanted to abstract away the toil, but then still give you all of the benefits so you can have the same benefits for your services. And so I wanted Anna to just talk a little bit about the systems you built, for instance, 12 years back, and now you're building systems out for cloud. How do you see that journey? What kind of systems are they? How different are they today from what you built 12 years back?
Well, I started in 2006, and at the time, Google had a couple of data centers, maybe 3, 4 at the time, maybe a little more, but we had a load balancer, and the load balancer that was in place was N-square load balancer, and it was like falling in pieces. So we built totally new control plane load balancer, global, that done wonderful work, and we organically grew it based on the experiences with these big customers that we had, which is a web search, YouTube, Gmail, each of which had a very different requirements. But most of them turn into requirements that are pretty much common to everybody else. They want to send data as fast as possible. They want to minimize the round-trip time for overall traffic globally. They want to make sure they can run their workload as cheap as possible. So that means that they want load balancer to distribute traffic in a way that it'll optimize overall capacity. And they want to make sure they can control and debug things, so there are administrative tools that built into the traffic management and stuff. So, and we thought, this is so Google, right? And then we go into cloud, and guess what? Our customers wanted the same. The interesting thing, though, that we learned a lot about it over years, and the customers are pretty sophisticated, and they want just right this moment, exactly this that we built over such a long time. So it's not that Google is very different. We were a little isolated and lived in this self kind of bubble, and the customers needs growing very fast, and their requirements are outpacing at this point internal Google requirements, which is interesting.
Sounds great. And then just building on what Bikash said, one of the interesting things he said is, as much as we want all of these technologies to appear in our networks and our deployments, the world, I mean, there is a lot of existing deployments, and we need to figure out how to get these deployments to whatever is the end state based on the goals of the customers. Now, one of the things I hear about all of these technologies, and actually believe it, but I also hear about it, is they are providing a lot of ways to solve the challenges that we face in a multi-cloud world. And even when we look at cloud customers, and I'm sure as you look at your own requirements, you probably have a deployment on Prem, and then you are in Google Cloud, and you're likely in other clouds as well. And then it's extremely hard to deploy and manage these. So one of the questions, and I want to see what their opinion is, do you believe fundamentally that these systems can be game changers for enabling you to deploy services, manage them seamlessly, or is there a big gap that needs to be filled before we can say that? Like, what is your take on that? And any of you can start, depending on.
I think the biggest problem, we've seen this every time there's new technology that comes out. There are some people who buy what the vendor's selling. They read the blog posts, they kind of copy and paste and retrofit, not really understanding the fundamentals. There are people who understand the fundamentals and look at these new tools and evaluate them on their ability to solve problems in that fundamental space. I think the challenge is we have so many tools coming out now, the pace of those tools, and you get really confused if you don't know what the fundamentals are. At the fundamental, you could look at Nginx, HA Proxy, and Envoy as doing very basically the same thing. And there's a higher level fundamental around configuration, right? How do you configure things? Most people are familiar with configuring things via a file and restarting something. And then you look at Envoy and you say, wow, this XDS protocol to incrementally configure a thing live. That's a big transition for most people. So that's how I fundamentally look at these things based on fundamentals and say, wow, Envoy is really bringing something new to the table. Fundamentally, it's routing packets around, but there's something different in the way you think. In order to take advantage of something like Envoy, you have to understand the ability to configure something that sits in the network the way it is, sets the stage for things like Istio and Traffic Director. without that understanding, all of this just looks like noise and confusion, and then someone has to try to convince you. And I think, unfortunately, we've been trying to do that through the sales motion and not the engineering motion of saying, this is what these things actually are, here's what they do, and it's okay if you want to outsource that to someone, but you got to understand what that technology is first so you can take advantage of it.
Yeah, you know, I think the biggest problem that I see is, like Kelsey said, there's so many technologies coming out right now, and there's this tension that we have from the tools where, and I see this all the time with Envoy, where we have a section of people that come to Envoy and they'll say, I don't understand this, it's too complicated, there's too many configuration options, I just don't even know where to start. And then we have another set of people that come and build absolutely incredible things that blow my mind without ever talking to me or anyone else on the project. So we have this tension. Clearly we have many different users, right? From people that want a prepackaged solution to people that want an extensible solution to build vertical things. And I think the key takeaway for me is that there is never going to be a one thing that fits every possible end case. And I think that we, from the infrastructure side, we have to build layered solutions, right? So there's going to be something like Kubernetes or like Envoy, which is more of a platform. And then we might have vertical solutions on top of that. And then we might have PaaS or functional platforms that sit on top and are more opinionated as we actually get further up the stack. And I think, right now we're still in that very early days of creating a lot of tools, and there's a lot of confused people out there, and I think we have to iterate to find the right layers of abstraction so that people can tap in at the layer that's most appropriate for them.
I want to add one thing. And I see this a lot with technology. When new technology comes out, there's a large population in the tech world that wants the new thing to work the old way. And this is what really slows down some of these projects, some of the momentum. You start adding a lot of cruft to these projects that they shouldn't be doing these things. But in an attempt to grow your user base, sometimes you will try to retrofit this new thing that has bought into this new paradigm to solve the old problems. And sometimes you just gotta draw the line and say, no, that's not what this thing does, even if it does cost market share or different use cases.
So I am a technologist just like everybody else is in the panel. I'll share a slightly different perspective. I spend a lot of time in my role with customers. And I think as technologists, we often forget usability. We go after, look how cool this thing is with what it does, but not how it actually solves a customer's problem. And you sort of touched upon that in the abstraction, but it's actually more than abstraction. If we don't understand the current state of an infrastructure of a customer, and if we show them the shining city on the hill, and we don't show them the steps to get to the shining city on the hill, and we tell them, by the way, where you live today, condemned house, forget it, it's not reality. It's not reality for any one of us. I'm yet to see, and I can only speak from network, I have built infrastructure for a long time in Google. I speak to a lot of customers all the time. I'm yet to see a single instance of a greenfield infrastructure. It doesn't exist. It's fantasy. So if it is fantasy, then the reality is we've got to build the steps. If we don't build the steps in technology, it doesn't matter how cool the shining city on the hill is. It's never going to be real. And I think, my view is that the technology world has often ignored the steps. And that does not mean that you actually drag your old broken house up to the shining city. But it means that you give a way to get to the end state where you are not layering yet another set of tools, yet another set of infrastructure. Unfortunately, one of the reasons for the explosion of the tools is because we haven't quite solved the old and we have a new one. And so we have layered yet another tool, right? If I happen to have infrastructure that must run on my 15-year-old database because that's where I have 100 million of my customers' information that no way I can migrate to something else in next 5 years, well, I still need to run that. And if I tell them that you're going to run that in the way that you ran 15 years back, which was throwing people at it, but you have all these new shiny applications that is fully automated, intent-driven, policy-operated, and this is a new way of training your workforce and operators. I don't think that's real because I don't think anybody has money to actually do it. One of the beauty of public cloud is that underneath, the infrastructure always changes. The stable APIs hide that. I know for a fact that GCP 7 years back is not what GCP is today with the infrastructure that it has underneath. But if somebody used APIs on GCP, most of those APIs are still the same. I think when the tools start doing that, where it's not really forgetting the migration, that's an important part for us to solve. We are definitely focusing a lot on that with Tungsten Fabric because most of the customers that we see, they absolutely want the world where a service mesh, where security is not a networking thing, security is an application thing. But they also run most of their applications on bare metal, maybe on VM in some scenarios. And if I tell them that your policy construct for service mesh is this, but in the old way, you're still configuring firewall policies, okay, we haven't really solved a problem for them. So I actually do believe that bridging the gap between the old and the new is a critically important component of the technology. And those that would do it, they'll win because the customers need that.
Some time ago, I set up to build intent-driven configuration system for service management. It turned out into success, but it only worked for 50% of services, worked well. For 35, it worked somewhat, and it didn't work for 15. And those 15 were probably the most important ones. They're big. They need every little knob you can even think of. And with that, I understood that we need everything. We need the knobs as the foundation, and we need to have them exposed. We need a simpler configuration on the top to help the 35%. And we do need intent. So I think we're at a point in the cloud era where we're still at the knob level. And I think if we do the knobs well, then the verticals on the top of it and intent-based system will grow next.
I'm going to add one thing. So before coming to Google, I've been in your position, trying to manage infrastructure. Maybe you share the same opinion. From a provider, we have to try to support everyone. When you're at your own company, you only care kind of about your use case, right? I've been in cases where we burnt the old house down so we can have the new one, and it's painful. Not everyone can do it, but you can do it. But as providers, we are kind of stuck in this situation where we're trying to go out of a large market share, so we kind of have these kind of tug of wars internally on what the feature set should be. And I think there's just different people who are concerned with different parts of that. When I looked at Envoy, I looked at it as a clean start. There's a clean start here to solve a very unique use case. I think Docker came from the same thing as a clean start to solve a unique use case. And then once it gets mass adoption, I think you start to have the ecosystem show up, and there are people who will help you adopt that thing, build a bridge technology. But I hope that we are free to continue to build things that don't work in the old world. And then maybe someone will come and bridge it, but I don't want us to try to figure out how to bridge everything because I think it will stifle new ways of doing things because we're always constantly stuck with the 20-year-old decisions.
So I'm going to open it up to audience. Before that, I pulled out a bunch of questions from the Dory and then also from LinkedIn and Twitter, and there are some really interesting questions. There was one for you, Kelsey, which said, how do you become good at so many open source technologies? These people are having probably some fan club out there, but they're having a hard time just getting their arms around Kubernetes, and then you're already on to Cloud Run and a bunch of different things. So how do you do that?
So 10 years ago, I came to the conclusion that there's probably nothing new, period. Just it isn't. There's data that comes in, you do something with the data, and you put it somewhere else. Oh, MySQL, Oracle, Spanner, doesn't matter. They all have their own little protocol. They're going to store your data in some format. The bytes are the same. I know you want to say it's cloud native or new or it's old, legacy, it's all noise to me. There's the fundamentals. So when I look at the fundamentals, bytes are moving around. How do you want to move your bytes? You want to move it with Envoy? Envoy has to move the same bytes in the same way that everything else has. It's free to have a new interface. It's free to do different performance things. But at the end of the day, those bytes have to flow in a certain set of directions. That's it. So when I see new technology that comes out for networking, it's very simple. These bytes need to go from point A to point B. What are you going to do with those bytes? And the same thing is true for compute. You're going to call instruction sets on this kernel, on this CPU. You want to do it with Golang? You want to do it with Python? You want to do it with Docker? At the end of the day, you're just going to make some system calls. So I never get tripped up and confused with the noise. I just want to know, how are you going to do the fundamental thing? And that's how I find bugs, and that's how I work through. That's all it ever can be, is the fundamentals. And then if you respect that and you learn the fundamentals, any new technology that comes out, you only have to ask one question: how are you implementing the fundamentals? And then that's my secret to doing that.
There's another question that, so I've been pulling these out of LinkedIn and Twitter that came for Matt. You developed a wonderful opens like a data plane proxy. Why did you not build out the control plane in open source?
That's a great question, and it actually comes back to what we were talking about before. Envoy is a very general technology, and it's extensible. It has a bunch of APIs. Like I was saying before, we've seen it adopted in a tremendous amount of use cases. And like Anna was saying, if it didn't have all the knobs, if it wasn't that base piece of technology, it would not have been adopted in all these cases. What you find at Lyft is that we have a control plane based on Envoy. We built Envoy, so the control plane has built up over the last 3 or 4 years. The control plane's a little embarrassing. Like I would not open source it. It's a mishmash of like Python templating and Bash and Go, and I mean, it's just, you all understand how these things go. And my point is that we don't expose all of the Envoy knobs to people at Lyft. We have service manifests, we have a configuration generator, we do all these things so that people at Lyft only see a very tiny subset of the Envoy configuration. But that also means that the control plane at Lyft is very specific to Lyft. And we're not, I work for Lyft, like I'm not building a product, and it just doesn't make sense to invest in trying to clean up that control plane in a way to open source it. That doesn't mean that we haven't open source libraries. There are libraries that we support in Envoy open source, like Go control plane and Java control plane. These are foundational libraries, but they're not complete solutions because they depend on our Jenkins and our Kubernetes and our legacy VM infrastructure, because we're not, of course, not only on Kubernetes. So it's really, again, just about those layered abstractions, and it just doesn't make sense for us to invest in open sourcing that control plane.
So there's another question. Thank you, Matt. And there's a question for Bikash. So this person says, as a Twitter user, the person says that you built these massive systems at Google, and they've been to all of your talks. And they're like, now as you are at Juniper, which aspects of those or which learnings are you utilizing at Juniper, and what are you doing differently?
Yeah, I think the best way that I can describe this is building systems in Google. It has certain expectations with who your customers are, and those customers are inside of Google. They're very savvy. They're very tech savvy. So you want to expose all the knobs, you want to make it highly programmable, you expect that there is a SWE on the other side of the system who is doing something very meaningful with the system that you've built. In many of the customers, the level of programmability that they can consume is different, and it's a spectrum. It's not the same for everybody. For many, usability is extremely important, and so my mission in life really has been still build open systems, still build system that is truly programmable, build system that has open API, open data model, but also build usability on top, where if somebody wants to consume a truly modern system, they can without having to really build the development team that Google has or can afford. And that has been a learning, sort of talking to, really spending a lot of time with customers and seeing they all have the same need. I think Anna was making the point that Google is not a bubble. Ultimately, everybody has a need for similar infrastructure, whether they consume it from cloud or whether they consume it internally, but making it usable for them and making it usable without having to make it proprietary. There is a bit of a tension in there, but I think it's doable, and that has been my goal.
And then the last question is for Anna, and then we'll open up to one or two questions to the audience. They say, like today, people saw the Traffic Director announcement. They know you're heavily involved. As you ship out all of these Google-specific products, should they use it, or should they be worried about lock-in?
Traffic Director has open interface to Envoys or any XDS compliant proxy. So it's the way to merge together all the value proposition as Google developed over these 15 years with the open interfaces and essentially producing open systems. So let's say you use Traffic Director today, and tomorrow you decided you don't want to use it. You build your own control plane. There's nothing that locks you into Traffic Director, because you just switch your point at which you're sending this APIs, and you get a different control plane functionality over the same APIs. We're hopeful that you're not going to switch away, because we're providing amazing functionality, but I'm not going to be selling here. But in general, as long as you have open interfaces, there is no vendor lock-in. So in my mind, the data plane needs to be universally open source, like Envoy or gRPC that is without a proxy. Or this basic transport needs to be open source. And then you have control planes that are sitting on the top of it with the open APIs, which are also removing vendors lock-in. And then the cloud providers can compete on the value proposition behind these APIs.
So I did want the audience, I want to give them the chance to ask 1 or 2 questions, and then you can find them after the talk, because I do want to end with their perspective. So if we can have, if you want to ask a question, we probably have only time for 1 or 2, but just use one of the mics so everybody can hear.
Just a question for you with regards to the Mongo's experiment with the server-side license. What do you think Mongo should have done, and what do you feel about the community's reaction to it? No volunteers?
Well, you know, this is actually what I was talking about before. Look, you know, no one does anything in this industry out of goodwill, right? I mean, let's just be honest. We're all here probably to make, we're all here to make money in some way. Some of us are selling infrastructure, some of us are building businesses, but very few of us, if we're really honest with ourselves, are here because, you know, this is the best thing that we can be doing on Wednesday afternoon. So, you know, with that said, if you look around at people's motivations, they're trying to build a business out of their software. The problem right now, and I don't really want to comment on Mongo or Redis just because you know, everyone has their own business situation that they're in. But this is directly related to what I was saying before about why I didn't start my own company, which is there's a tension between locking down open systems and software and trying to charge people for those systems versus building a welcoming, larger community, which is extensible and then allows everyone to succeed. And this is very subtle. I've written a blog post on this, which you could check out if you want, but I think there are ways of building viable vertical businesses on top without alienating people on locking down, you know, certain pieces of the software. So what I would say, again, without specifically commenting on particular companies, I think there are ways that it can be done, but it's a very complicated problem.
So we can probably take one more question. Oh, you want to add?
Yeah, so maybe I'll add, not answering specifically to MongoDB again because I don't know what their business model specifically is. I think there is a misconception that open source is free. It's not free. The software developers have to make a living by writing software somehow. And there has to be a business model somehow for the software developers to make money to make a living. The part that I found is very important is to be very clear about the business model that you have around open source, which sometimes is not true. And changing the business model mid-course actually can be very problematic for the community. And I think that's the problem. The problem is if we don't have the business model laid out very clearly from day one, Tungsten Fabric has a business model of open core where the stuff that is open source will always remain open source, period. It doesn't matter whether a Juniper Competition is building a product with Tungsten Fabric, it's going to remain open source because that's the charter in Linux Foundation. And I think, you know, having that clarity with the business model is important because otherwise people build this mistaken assumption that somehow open source is free. And now you try to figure out how to monetize it. And that's the problem.
Kelsey says, let's take some more questions. So let's take some more questions.
We can be really tight with our answers as
Yeah,
well.
and
I mean, you guys are here in person, so we appreciate
and it's
that.
your panel, so go for it. If you want to ask questions, just use one of the mics, though, so everybody can hear.
So the way I see Kubernetes is that it's a level playing field for the way you build and deploy containerized applications. And Kubernetes is available both on-prem and in all the public clouds. Is there an answer, do we need an answer for network security storage that's similar to Kubernetes and do we have an answer?
The thing is, I think you're going to need someone with that level of experience, willing to build a system in a very similar way that Envoy did and Kubernetes did. And I think that's going to be very hard. We saw it with Git, with source code, or source tree management. We saw it with Linux. So I think a lot of people have the right motivations, but you need all the other factors. And I think it's very rare that you'll see an Envoy come from a place that it came from. I think it needs to solve a real problem first for at least one company first and put it out there. And if people think it can be generic enough that a lot of people want to use it, I think that'll work out well. We saw this with like HTTP, you know, there's a standard around it. Lots of people can implement it. But the problem with networking, it's a lot of cultural things that are baked into how you lay out your network. Right? There's different architectures. To me, networking is closer to programming languages. You can decide what architecture you want your network to take. Some InfoSec teams won't give out more than 10 IP addresses. They count them like, no. These private IPs, we're only going to give you 10. It's like, what the hell are you doing with them? They're fake, actually. You can make more of them. It's very cultural. I have not seen, you know, to me, I think the networking problem is that it's so cultural for these companies. Even if I gave you the best networking tool, like in Kubernetes, the culture is going to dictate how it gets used. That's the features you're going to ask for. So I think Kubernetes is a little bit easier because, again, you're just making some system calls, wrap up your code, put it in a container, it's going to run it for you. So I don't know. Someone may try to do it. I think Envoy gets us very close. But in terms of how you lay out an architected framework for your internal network, I don't know about that one.
Any other questions? We can probably take one more, otherwise I want to put the panelists on the hot spot, so I can do that instead.
Do it.
Do it? Okay. So, you know, each of you, like I think you rightly pointed out that different companies have different motivations for doing all of this. When I look at each one of you, there are several things, as Kelsey pointed out. We have a very heavy-duty title for this talk. And so I wanted to put each of the folks here on the hot seat to answer a few questions. Like we spoke so much about open systems and making the switch from whatever your deployment is today and then somehow migrating it to from like whatever your end goal is. So bringing all of this to your brownfield and so on and so forth. But if you, let's say, look 2 to 3 years ahead, let's say we have all of these open systems, we have all of these paradigms. What has it enabled? Like what kind of businesses do you see? What kind of problems solved? What kind of communities? Are we even going to be talking about Kubernetes and Envoy and Service Mesh and all of that 2 to 3 years down the line? Or will the conversation be totally different? And maybe we can start with you, Bikash.
So I think the very nature of applications and users are evolving, so it's a given that the infrastructure is going to evolve. I think that's one thing that we know for sure. Everything else is pretty much a guess. I do think that being open is a necessity in the world that we live in, and the reason being, ultimately, you know, sometimes I get this question of what is cloud? It's a set of stable APIs on an infrastructure that the APIs hide from you. That's what it is. And of course, the infrastructure evolves over time. It's true for everybody, whether it's public cloud or private cloud. It's the well-defined abstractions and API that make it durable and usable, right? So I think the need for open is coming from the fact that you want a part of the infrastructure that you can use for a long period of time, while the underlying scaffoldings would change over time, and you don't have to reinvent your infrastructure every single time. So I think we've seen that. If you look back 20 years in how compute was done, you know, the basic Unix system calls haven't changed that much. The underlying scaffoldings have significantly changed.
I think my view and the thing that I typically tell people is that, you know, all of us that are sitting here building infrastructure, we're doing it to support application developers building business logic. Like, that's the entire point. I mean, infrastructure is overhead. There's no point to it, right? I mean, the way that people make money is by writing business logic. So, you know, I think my goal, and this is not a 3-year out, this is more of a 5 to 10 year out, is that I think ultimately I do believe in the quote serverless paradigms. And just by that, I mean that in the long run, as Kelsey was saying, you want people to write code and store data and talk to things. That's it. That's all application developers care about. They don't care about container systems. They don't care about networking. They don't care about routing. They don't care about failover. And so I guess my view is that our goal is to make it so that no one even cares or knows about Kubernetes. They don't care or know about Envoy. Like, Envoy is a transparent thing that provides functionality, and all people are doing is the fundamentals. And we're so far away from that right now, and that's what excites me, is that we have many years of building better abstractions and better systems so that the fundamentals they just get to people in a much simpler fashion.
Yeah, so I think if you look at like programming languages, so if you look at neuro programming languages, I would even put Python in that category, and like Golang, they have very extensive standard libraries. Like Go has this very robust HTTP server where typically you don't need to front it with anything. And a lot of the libraries that you see in the standard library allow you to compose just software that's ready to go on the network. That was Go's goal. If you think about this from the platform perspective, so platforms are evolving from just these bare metal machines, Linux, systemd, init systems. And now that we're in this like Kubernetes era, serverless eras, I think Kubernetes and Envoy just become standard libraries for platforms. If you're gonna build a platform to talk about Matt Skoll, you're just gonna look at these as standard libraries, all right? I need something to handle this network layer. I need something to handle the compute layer. You're just gonna import those into your stack. And the thing that you build on top will be that higher level thing. That's what Go's trying to do for you. You build programming logic. You don't think about SSL handshakes. You don't think about HTTP handshakes. All you do is import the library, you write your handler, and you handle the request. These things that we're working on is all so you can have that platform at top. So I think that's the best way to start thinking about the future of these things. Start at, what do you want to do? What's the minimal required to do it? And all the things that are getting in your way of the minimal requirement, that's the things that we probably need to flesh out and build, but that's the things that will underpin the long-term platform.
I agree with everything being said here, but I always say that in 5 years, network will disappear. Nobody wants to program networking, right? You find one developer who actually interested in it. So networking will disappear. All the container management also. And over here, you'll have a different panel. You have a panel of business developers who are going to be talking to each other how to federate, how to make their vertical into horizontals, because at that time, the conversation will move a layer up, right? And I'm not saying that we're going to become a dinosaurs, but by that time, we actually going to we either solve the problem or we're going to be where we are today. So we need to solve the problem to become universal, very much horizontal across different environment, make workloads be the same no matter where they run, and basically solve the problem that we discussed today.
I'm going to add one thing. The time horizon, everyone thinks that this is 5 years away. I was at KubeCon, and everyone's talking about Kubernetes and service meshes and all these things. And there was a person there with a Google Cloud t-shirt. They were a customer. And they're like, I am so glad we just used App Engine 8 years ago. I don't care about any of that. And they run a real business, right? It's not a fancy startup. They just don't care. And they're like, why are people trying to rebuild App Engine from scratch? And so the thing is, some people have this reality. I'm not saying that it's going to be reality for everyone. There are people who've had this reality for a long time. I think most people need to just convince themselves, you're just trying to build the same thing. You just feel more comfortable doing it from, I think, the steps. This is your stepping stones. But if you step back, and I tell a lot of our customers, you really want to build App Engine from scratch? I'll show you how, but just know that's what you're doing.
Yeah, so I think the reason for getting all of these folks here, and we're almost at the end of the panel because they wouldn't give us more time, but the reason for bringing all of these folks is, these conversations are starting. These are just the beginnings of a lot of conversations around open systems, open interfaces. As each one of us here goes and builds out these technologies and open source, even within Google, at Juniper, and so on and so forth. And the whole goal was to get you folks as well thinking about the open interfaces. Also how whatever it is that you build has a way for the community to also benefit from that, and also your own business as well, because everybody is in it to create a business out of things or to solve a particular problem. And so one of the things I highly encourage is to also engage with these folks on Twitter, LinkedIn, other forums, and then keep the conversations going. So thank you for coming, and thanks to all of our panelists. Please give them a big hand.